First thing today we're going to look at is a type of problem that we call where to place a third charge so it experiences no net force. It's not a great title, but you get the idea. I have a physical setup here where I have a positive 2 microcoulomb charge and a positive 4 microcoulomb charge separated by this distance. What I want to know is where should we put a third charge so that it experiences no net force, meaning whatever each one of these does to it is canceled by the other. In these setups, we're basing the force on Coulomb's law. And how I approach it depends on whether these charges have a like sign or a different sign. These two charges have a like sign. You can see that if I put the -3 over here, it would be attracted by the 2 and attracted by the 4, and therefore those forces wouldn't cancel. If I put it over here, same thing. Both of the forces would be going in the same direction and they wouldn't cancel. However, if I put it in the middle, now it will be pulled one way by one of the charges, pulled the other way by the other charge, and I have a chance of these two forces balancing out. Whenever we have the original charges have like signs, we're going to put the third charge between. Now I'm going to solve it. I want to figure out what this placement is. This force of attraction is the force between the 2 and the 3. This force of attraction is the force between the 3 and the 4. I want these two to be equal. I want the force between the 2 and the 3 to be equal to that of the force between the 3 and the 4. Using Coulomb's law and substituting in, K times 2 times 10 to the -6th times 3 times 10 to the -6th over this distance. I have not yet defined my distances. I'm going to call this distance x, which means this distance would be the remainder, or 0.8 minus x. Since I'm talking about the force between the 2 and the 3, this will be over x squared. That'll be equal to this force, K times 3 times 10 to the -6th times 4 times 10 to the -6th over 0.8 minus x quantity squared. This looks like a mess to solve, and it's not that bad because a lot of stuff cancels out. So first of all, the k's cancel. 3 times 10 to the -6 cancels. Of these, the times 10 to the -6 part can cancel. So simplifying, I have 2 over x squared equals 4 over 0.8 minus x quantity squared. For this part of the problem, I'm now going to square root both sides. When I square root both sides, then I'll have rad 2 over x equals 2 over 0.8 minus x. Cross multiplying, I'll have rad 2, which is 1.414, times 0.8 minus x equals 2x. I'm going to distribute and I'm going to simplify. I get 1.13 equals 3.414x. X equals 0.33 meters. I have my answer to the problem, but I need to put it in a little bit of context. I defined x as this, so I should say 0.33 meters to the right of the positive 2 charge. And looking at the magnitude of this, 0.33 is less than half of the 0.8, which makes sense because if 0.2 is a weaker charge than 0.4, it's going to need to be closer to that than it is to this.